Morning everyone. My name is Jubair Hussain and I am presenting on behalf of Group 2 for MDA621 Assessment 2. Our presentation is divided into two parts. Part 1 covers airline on time performance data analytics using Apache Pig Latin on AWS EMR with Tableau visualizations, and another part 2 covers the oldest Brazilian e-commerce dataset using HypeQL. I'll now hand over to Mahirul to walk us through the part 1 overview and setup.
Hello, this is MD Mahirul Islam, and I will be talking about the task 1 of our assessment 2. So basically here we have worked on the airline data. So first we have done the HDFS setup, then the directory, and then we have transferred the data set. So in the doc file, I can show you that. So here is the cluster that we have created for the task 1, and later on our Win SAP we have transferred the airline data from our local system, and then we have just written the required code for every task. Going back to the slide, and these are the all things, these are already mentioned. So the original dataset is taken from Kaggle, and my another team member will be talking about the dataset and the required code for the assignment. And on the last step we have done, we have saved the outputs to analyze in the Tableau software.
Thank you, Mahirul. I wrote the pig script for task 4, which computes the total number of flights per month for each year. The script loads the airline CSV from HDFS, filters out the header row, then extracts the year and month from the flight date using substring. Then we group the data by year and month, count the flights in each group, order the results, and store the output to HDFS. The script was run using the pig-f command from the master node terminal. Once all three pig scripts were run, we excited the grunt shell and used Hadoop fs commands to verify the output directories were created correctly. We then used Getmerge to download each output, flights per month and average monthly delay and average delay per airline as individual CSV files to the master node, ready to be imported into Tableau for visualization. Now I'll hand over to Kaushik for task 5.
Hi everyone, I'm Kaushik. I will present task 5 pig script. Thank you Jobair for giving me the chance. I wrote the pig script for task 5 which computes the average monthly arrival delay for each year. This script is similar to task 4 but adds two important filters. We only include flights that were not cancelled and we exclude rows where the arrival delay is null. We then group by year and month and use the average function to calculate the average delay. The results are ordered and stored to HDFS for later visualization in Tableau.
Thank you, Kaushik. I wrote the peak script for task 6, which computes the average arrival delay for each airlines per year. The scripts add an extra filter to exclude rows, whether the airlines field is set to all airlines, which is an aggregate row in the dataset. We group by year and airline, calculate the average arrival delay, and the order the result alphabetically by airline within each year. The output is stored to HDFS and later downloaded as a CSV for Tableau visualization. I will hand over to Mahirul for the Tableau visualization.
So here we have the Tableau software. So the first task was to analyze the freight volume trends. So basically here we can see we have the record of every year and every month that represents how many flights were there. So basically we can have a look that on 2022, on month 3, total number of flights were 475. So basically, it represents that during the COVID time, there was very less amount of domestic travel. So after days have passed, the ratio have increased. Then we have done the average monthly delay. It represented that every year and every month, what was the average delay. So for example, in month 1 in the year 2020, the average delay was 30 minutes. So basically, we can see that the bar is like fluctuating. And talking about the airline's performance, so it represents that about a particular airline and its average delay per year. So basically, if I talk about this one, the airlines Bonza in the year 2023, the average delay was 28 minutes, and but the in the year 2024, the average delay was increased to 33 minutes. So basically, we can say that the performance of these airlines become very worst. So if I'm talking about all the stuff over here, it's gonna take too long. So I'll just pass into my another team member to have a discussion with the codes and the rest of the things. Thank you.
Hello everyone, this is Tasin, and here is a quick overview of part 2, what part 2 will cover. We will go through the environment setup, database, and environmental setup, database creation, um, table creation, and walk through our HiveQL queries that we have in the document, um, covering data retrieval, product category analysis, retrieval, uh, payment behavior, and regional trends, and finally wrap up our key findings. Here is the document where we have shown all the analysis and all the data outputs we got from our analysis and everything. Moving on to our slide. For part 2, I handled the complete environmental setup. We had 5 CSV files from the OLIS dataset: orders, order items, order payments, customers, and products. As you can see in task 1, I have created the files, and here are the data customer data sets that we have here, and all the all the tables that have been created in task 3. And then all 5 files were uploaded to HDFS under the path excuse me, under the path p user slash hadoop slash olis sales, with each file placed in its subdirectory that I have made here. I then created the Hive database called olist, called olis sales, and yes, as you can see here, we can see the olis sales here, and then we have created the tables.
For task 4 in part 2, I wrote the HiveQL join query that retrieves order ID, customer ID, seller ID, product category, payment value, and purchase timestamp by joining 4 tables together. Those are orders, order items, products, and order payments. As you can see from the sample output, the results show a diverse range of product categories being purchased across Brazil, with payment value ranging from $25 to $260, just within these 20 records. Now I will hand over to Kaushik for task 5. Thank you, everyone.
In part 2, I wrote the query to find the top 5 product categories by average payment value. The result shows that PCs led the list with $1,268 average, followed by Telefonia Fixa at $763 and Portates Casa Forno e Cafe at $656. Electronics top the list because they have naturally high unit prices and customers make infrequent but large purchases. Agroindustria made the top 5 because agricultural and industrial goods are often bought in bulk by small businesses, pushing the average up significantly. I also ran task 9, which analyzed payment types. Credit card was overwhelmingly dominant with 76,795 transactions and an average payment value of $163. This is largely due to Brazil's parcelamento culture, where the customers split payments into 6 to 12 monthly installments. Boleto came second at $145, followed by debit card and voucher. Vouchers had the lowest average at just $65 because they are typically promotional discount used on lower value purchases. Thank you, and now I will hand over to Sohan.
I ran task 8, which identified the highest payment value order for each customer state across all 27 Brazilian states. Rio de Janeiro recorded the highest at 13,664, followed by the Espírito Santo at 7,274, and Mato Grosso do Sul at 6,929. The southeast state lead because they from Brazil. They form Brazil's economic core. Higher thousand household incomes, better internet infrastructure, and stronger e-commerce adaptation all contribute. At the other end, Roraima recorded the lowest at just 994. It is Brazil's least populous state in the Amazon region, with limited logistics and lower purchasing power. I'll hand over to Apuno.
Thank you, Shohan. I analyzed task 7 and task 10. For task 10, we compared delivered versus cancelled orders. The data showed that 96,477 orders were delivered with an average payment of $153, while 625 cancelled orders had a notably higher average of $215. That is 41% higher. This is a really interesting findings because it tells us that higher value purchases are more likely to be cancelled. Customers experience more hesitation and payment difficulty on larger orders. For tax 7, we found that orders with freight cost above $50 were almost exclusively paid by credit card. This makes sense because bulky expensive items require the installment flexibility that credit cards provide. There is a clear business opportunity here to target high value orders with retention strategies to reduce cancellations. I will hand over to Tasin for the final summary.
And now I will cover the key findings that we've got in our analysis. So our five key findings: first, product categories led all product with an average payment of value 1268, and PCs led the average. Electronic, which falls in electronics and bulk agri goods, dominate high value purchases. Secondly, credit card dominated with 74% of transactions. This reflects Brazil's installment payment culture, where customers split costs over 6 to 12 months. Thirdly, there was a significant uh, 14 months, 14 times regional spending gap between Rio and Roraima, and Rio spends around 13,664, and Roraima spends about 994. There is a huge gap between these two. And fourthly, we have seen cancelled orders had 41% average higher average payment value than the delivered ones, suggesting that buyer hesitation on larger purchases a clear retention opportunity for the business. And finally, orders with freight above $50 strongly correlated with credit card use, as customers buying bulky expensive items prefer the flexibility of installments. Thank you everyone. This concludes our presentation.